First order linear differential equations. This, I think, is the most important technique that we're going to learn in the whole course for a couple of reasons. One of the reasons is it solves a whole class of differential equations. So we know what it means to talk about the order of a differential equation. It's the highest number of the derivative. So first order has just a y prime in it. Linear means, again, linear in terms of y and its derivative. So if I'm talking about first order linear, I mean that it's linear in terms of y prime and y. So all first order linear differential equations can be put in this form: y prime plus py equals q. So p, I've got it written down here, p of x. P could be a function of x. Could also be a constant, but it could be a function of x. Q could be a function of x. So if you've got a first order linear differential equation and you want to use this technique, this y prime plus py equals q technique, the first thing you should do is put it into that form: y prime plus some function of x, p, y prime plus py equals q. Once you put it into that form, the next thing we want to do is multiply all three sides. So by the three sides, I mean the y prime is one side, the py is another piece, another side, and the q is the other side. So you want to multiply all three sides by this integrating factor, e to the power of integrate p dx. So just a little caution here. Note there's a 1 in front of the y prime, or there's a nothing in front of the y prime if you want to think about it that way. So when I multiply through by this integrating factor, the purpose of it is to integrate this hand side, to integrate the left hand side. So once I multiply through, the left hand side then is y prime integrating factor plus py integrating factor. Now that left hand side always integrates to be y times the integrating factor, y times the e to the integrate p. All right, I'm just saying that. Why does it? Well, why does this integrate to this? Because, now the easiest way to show it is, let's differentiate. Let's differentiate this product. Remember, y is a function of x, and e to the integrate p is a function of x. So let's differentiate this side. So I'm going to differentiate this. Product rule, derivative of the first, y prime, leave the second alone. Plus, leave the y alone, times the derivative of the second. But what's the derivative of e to the something? That's going to be the derivative of e to the something is e to the something times the derivative of what's up top. So I have to multiply by this derivative. What's the derivative? There's a chain rule. What's the derivative of integrate p? Well, that's just p. So if I differentiate this top, I get this bottom. So if I integrate this bottom, I get this top. Just mumble something about fundamental theorem of calculus, one of those fundamental theorems of calculus. So the whole purpose, now this seems weird, why would I want to multiply through by this factor, this odd looking factor? The whole reason I want to integrate, I want to multiply the first order linear differential equation through by this factor is it sets up the left hand side to be perfectly the derivative of y times the integrating factor. So when I do that and I integrate both sides of the equation after I multiply through, the left hand side is always going to integrate to be y times the integrating factor. What does the right hand side integrate to be? Well, depends on what the q is. Let's see. Let's start again here with this idea. Here I've got my y prime plus py equals q. My differential equation is in the correct form. I multiply all three sides through by this integrating factor. And then from this step to this step, I'm integrating both sides of the equation. I'm integrating both sides of the equation with respect to x. So integrating the left-hand side with respect to x, integrating the right-hand side with respect to x. I know what the left-hand side with respect to x integrates to be. It's just y times the integrating factor. We prove that up here. That's why we multiply through by that weird-looking integrating factor in the first place. What does the right-hand side integrate to be? It depends on what q is. But q is a function of x. E to the integrate p is a function of x. This whole thing inside this square bracket is all x's. So it's finishing this, integrating this side, is just a calculus problem. Integrate that side with respect to x. Let's do an example. So this first example is already set up in the right form. Y prime plus py equals q. The p then is the 2x. So I need the integrating factor. E to the integrate 2x dx. So that's the integrating factor. Let's simplify it. I'm integrating that 2x with respect to x, so that's just e to the x squared. So our integrating factor, e to the x squared, that's what we're going to multiply all three pieces by. So I'm multiplying the y prime, the py, and the q part. Now the next step is to integrate both sides. Integrating the left-hand side is always going to integrate to be y times the integrating factor. So there's me integrating, I integrated the left-hand side. Integrating the right-hand side, well, I'll type this in as that's the problem I have to do. But how do I do that? Well, it depends on what the structure is. In this case, it could be just a u substitution, or I think I can see it as e to the x squared with a half. So I can get that with a u substitution, or sometimes we have to do integration by parts, whatever technique you got to use to integrate this right-hand side. But there it integrates to be 1/2 e to the x squared in our case. Now, at this stage is when I integrate both sides, that's the stage I put the plus c on. So now I've got there's my implicit solution. If I want my explicit solution, solving for y, I'll take this expression and either divide everything out by e to the x squared, or probably better to multiply everything here by e to the minus x squared. So I cancel out the e to the x squared. And there's my explicit solution. How do I get this c? I could plug in the initial conditions. But notice, if I forgot the c when I integrated both sides, then there would be no c. This piece would be gone, and I would just get y is equal to 1/2. Or if I didn't put the c in the right place, so let's say I integrated, solved, got 1/2 for the explicit solution, and then just tacked on a plus c at the very end instead of putting it in the right spot, then I just get 1/2 and then tack on a plus c. That wouldn't be, I wouldn't get the right answer if I put the c in at the wrong time. Now, okay, there it is, there it's solved. We don't have an initial condition, so I can't get the c. The only thing, let's go back to here. When I integrated both sides, from this step to this step is me integrating both sides, and the left-hand side I integrated by just saying the left-hand side always integrates to be y times the integrating factor. I just proclaimed it. Well, that's why we multiplied through by that weird integrating factor in the first place. Let's check though. If I differentiate this left-hand side. Product rule, because y is a function of x and e to the x squared is a function of x, we can see derivative of y prime, leave the e to the x squared alone, plus leave the y alone, times the derivative of e to the x squared. The derivative of e to the x squared is e to the x squared times 2x. It does work. If I differentiate this, I get this left side. If I differentiate this left side, I get this left side. So if I integrate this left side, I get this left side. We integrated, though, both sides with respect to x. Let's do some more examples. So here's, I got y prime, move that up. Y prime equals 2 over xy plus 7. First, I recognize it as it is first order because it's only got a y prime, and it is linear because it's a linear combination of y and y prime, but it's not in the right form yet. We're not ready yet for this. So I need to move this piece over to the other side. Now it's in the right form. Y prime plus py equals q. So now let's get the integrating factor. The integrating factor is going to be e to the integrate. Now, the integrating factor in this case is minus 2x. The minus is part of the integrating, is part of the p, sorry, because it's supposed to be y prime plus py equals q. So in this case, let's write that down, p is equal to this minus 2x. Now let's do our integration here. That's going to be e to the, that's going to be minus 2 ln x. I'm ignoring the absolute value thing for a second because I am. So I've integrated this. But one of the things that we should do then is to fully simplify our integrating factor before we multiply through. And what I mean by that is if I have a ln inside the integration like I do here, then I should use the fact that e and ln are inverse functions and cancel each other out. So that's going to be e to the ln. I'm bringing that minus 2 exponent inside the ln, and now I can cancel the e and the ln, so this whole integrating factor is just x to the minus 2, or I could write that as 1 over x squared. So my point in this example is there was two things. The first thing is the original problem wasn't presented in the y prime plus py equals q, so we had to make it into that proper form. And then the other point so far is that if my integrating factor has a ln and an e, I have to do some manipulation to cancel those out. E to the ln something is just that something, so I had to do some, put the exponent inside first. So long story short, there's my integrating factor, 1 over x squared. So I'm going to take my original problem and multiply all three pieces by 1 over x squared. So that's going to make this cubed if I multiply by 1 over x squared. So that's this original equation in the right form, y prime plus py equals q, and I multiplied all three pieces, all three sides through by the integrating factor. Now I'm set to integrate both sides. The left-hand side always integrates to be y times the integrating factor. The right-hand side, well, that integrates how it integrates. Notice that that's just a function of x. Let me think about it like x to the minus 2 here, so that when I do integrate, I'm integrating this piece. In fact, let's just write it down. Integrate That's going to be a straight add 1 to the exponent, divide by what's up top. At this stage, I put my plus c, and now I've got my implicit solution. And if I want my explicit solution, I guess I could take this piece, this equation, this implicit solution, and multiply everything by x squared. And there's my explicit solution. At this stage, I could solve for the c. Let's do another example, because this technique is extremely important. If I'm thinking about, I know the final exam's quite a ways away, but guaranteed there's a y prime plus py equals q type. There's a first order linear differential equation to solve. Guaranteed this is on the final exam. Guaranteed this would be on a midterm. Quizzes, it's on everything, because it's probably the most, it's not in everything, it's in many things, because it's one of the most important techniques that we learn, because it solves a whole class of differential equations. When you get to the tank questions, the pumping brine from here to there tank word questions, most likely the differential equation that you need to solve will be a first order linear differential equation. Let's look at some more examples. So now, I've been given an initial condition, which means that when I do get the c in the right place, I'm going to be able to find what that c value is. So let's look at this differential equation. xy prime equals, it's first order, and it is linear, but it's not in the right form. It's not in the right form for a couple of reasons. The main reason, though, is it's supposed to be y prime, not with this x. So the first thing I'm going to need to do is divide everything out, divide that x out. Okay, now it's y prime, but I'm going to need to make it y prime plus py equals q. Now it's in the right form. This is the same differential equation as the original, but now I can pick off what the p value is. P is equal to minus 1 over x. So my integrating factor, e to the integrate p, is going to be e to the minus ln of x. And we remember from the last example that I'm going to need to cancel off the e and the ln. So I'm going to bring that minus 1 inside and make it e to the ln x to the minus 1, or e to the ln 1 over x. In the end, I'm getting 1 over x as my integrating factor. Now this seems a little fishy, right? That's like just the negative of my p-value. Okay, let's go with it though. We'll check. Oh, not that. Let's save this initial condition here. All right. Here's my differential equation in the right form. I have like 3 versions of it. I want this one because it's in the y prime plus py equals q. And I know what I'm supposed to do. I'm supposed to multiply all 3 sides by the integrating factor, which just happens to be 1 over x. So it looks, we're a little suspicious here right now, but let's go with it and see. So I took this and I multiplied each of the 3 pieces by 1 over x. Now I'm going to integrate both sides. The left-hand side, if everything is right, is supposed to integrate to be y times the integrating factor. So that's integrating that. Integrating the right-hand side. Okay, we haven't done that yet. But let's just check. Here's me integrating both sides. I integrated the left-hand side. It's supposed to, if everything we've done is right, it's supposed to integrate to be y times the integrating factor. Let's check by product rule. Derivative of the first, y prime, leave the 1 over x alone, plus, leave the y alone. The derivative of x to the minus 1 would be minus x, subtract 1 from the exponent. Yeah, minus 1 over x squared. So it is right. We've integrated both sides, and the left-hand side integrated to be y times the integrating factor. The right-hand side, let's integrate that now. Integrating minus 2 over, that's minus 2 ln absolute value of x. At this stage, we put in the plus c. And so I've got my implicit solution. Okay, now we could solve for the explicit solution and then get the c because we have an initial condition, or we can get the c now by subbing it in. Let's get the c now. I'm going to make x equal to 3 and y equal to 2 in order to solve for the c. So if I make x equal to 3 and y equal to 2, that means that c is equal to, just move that minus 2 ln 3 over to the other side. So there's our c value. That's some kind of a number. So our solution, our implicit solution, no, our explicit solution, I'm just taking, there's two things I'm going to do. I'm going to replace the value of what c is by what we know c is, and I'm purposely removing the absolute value bars. Why? Because I know that x is positive because they're telling me that x starts at 3. So I don't need the absolute value bars. There's my implicit solution. If I wanted the explicit solution, I just multiply both sides of this equation by x. I guess someone's probably going to wonder, why didn't I put the absolute value bars in here when I integrated? Because I saw, there's a couple of reasons I could say. One of them could be I saw that x was going to be positive, so I didn't need them in that case. Another reason would be if I integrate that with the absolute value bars, then there would be absolute value bars over that. Again, with the 3, it cancels out. Oh, another question that sometimes people have is, how come when I'm integrating this e to the integrate p that I don't include a constant there? The answer to that is, there's two ways to look at the answer. The easy way is I just say, don't worry, it doesn't matter. Some people are satisfied with that. If I want to show you that it doesn't matter, let's go back up here. If I did have a plus c on each one of these pieces, then that would be an e to the c, an e to the c, and an e to the c on all 3 sides. Then I could just cancel it all out before I do the integration. So yeah, it doesn't matter. Let's do some more examples. Oh, actually, let's look at this example. Y prime, it's first order, but it's not linear. There's no way I can do any kind of manipulation with this to put it into the y prime plus py equals q format. So it's not first order linear. Can't do this one. Well, I need to use separable equations. It's not this part of this technique. What about this one? It's first order, oh, it is y prime plus py equals q, or it can be made to that form. Let's multiply the x up, cross multiply the x. Now it's y prime plus py equals q. So now I've got the integrating factor to multiply through by. The integrating factor would be e to the integrate 2x. So it would be e to the x squared is my integrating factor. Multiply all three sides through by that. All three sides through by that. Integrate both sides. The left-hand side always integrates to be y times the integrating factor. The right-hand side, this looks like we already saw this integral of e to the x squared. So this is going to be 6 e to the x squared plus c. And since I'm not given an initial condition in this problem, and I'm not told whether we need an explicit solution or an implicit solution, in that case I'm just going to leave it as the implicit solution, and I'm done.